Hi, I'm going to show you how to leverage a Python anomaly detection algorithm called isolation forest and create a dashboard with Power BI. The first thing I'm going to do is walk you through the code. It's not that complex, and then pipe that over into Power BI and then visualize all this in a dashboard. So the first thing that I'm doing in my Jupyter notebook is loading in all the essential libraries. So I'm importing pandas so we can manipulate the data, importing NumPy uh, for mathematical functions, matplotlib for visualization. And here is our algorithm that we're using from the sklearn library, which is called isolation forest, and it's kind of like a decision tree algorithm, but specifically for anomalies or outliers. I just have a random state here so I can produce the results. I'm importing warnings because sometimes the warnings pop up if something is not updated. Then I'm loading in my data set, which is a machine temperature data set, and I'm looking at the head and we can see the values here, and we can see that it's timestamp, and then we have temperatures here. The data type I'm just looking at here is a float to make sure that's going to go into our model a little bit better. Then I just change the index, instead of having this index, over to um, the date. I reset the index, and then I wanted to visualize this with a scatter plot. So I used the index, which is at a date level now, and here is the values, and we can see that they pretty much adhere around 45, but we have some outliers up here and some here. And then I just used the summary statistics function to kind of get some statistics around what the data looks like. We have our 25th percentile here and our 75 percentile here, and then our max value, which I would assume is this value here. And I didn't use train, test, and split here because this is an unsupervised model. So I decided to create some outliers and test the models on that. So I'm going to train the model on the entire data set, and then I'm going to test it with these two data frames. So I use the 95th percentile and the 5th percentile to create a high outlier data frame, which would be um, this upper bound limit, which is anything starting at the 95th percentile, and then anything 1.5 higher, and then a low outlier, which is the lower data frame at 0.5, which would be the 5th percentile, and taking anything lower than that for a data frame. And you can see that here. Then I instantiated the model. I fit it to the entire data frame, and then I created a prediction column, and I added that back to the data frame. So very quickly, I want to show you what we can alter in terms of parameters. There's a lot of parameters. However, the one that we will alter, in our Power BI dashboard or in this would be the contamination, and this is the amount or proportion of outliers in the data. And you can see it's set at auto, and we can change this from 0 to 0.5. So after running that, I can see that our outliers were found here. We had it gives you a value of a 1 and a negative 1. 1 is the inlier, so what your regular data is, and this 0.1 would be all sorry, not 0.1. The negative 1 would be the identified outliers. And if we ran that on our data frame, a high outliers, we can see that it found all of those mostly, and then we have some here that are ones. So that looks pretty good. And if we put this in the low outliers, we probably would get different results. So I'm just going to change that and run it. Oh, I didn't run it from above. Let me just quickly run all these. So we also picked up a lot of our low outliers. And we can see that value changes. And then I just pickled the model because I was hoping to bring in the trained model into Power BI, but I wasn't having a lot of success. So if anybody knows how to do that, I'll be happy. I know you can do that with some auto ML like PyCaret. So let's reproduce this in Power BI and create a dashboard, and we don't need as much code at all. So let's go over to Power BI and port this data in. So I'm just going to go to the get data. I'm going to go to the machine data that we have saved, and we can see there all our values there. I'm going to load that, and then we can see that that's in Power BI. I'm going to go over to transform and bring up the query editor, and we can see our data is there. The first thing I like to do is duplicate the data set to run my code on the duplicated data set. And then I am going to go over to transform and then run Python script. And then we're going to do a modified version of what we created in the Jupyter Notebook. So now that we have this open, we can go and copy over some of the code that we already have and modify it. So I'm going to go back over to the Jupyter Notebook, and I'm going to take all of this, but we don't need warnings because that's something that's specific to Jupyter Notebooks. Go back over to our script editor, and then we have that in. We can go over and get a little bit more code and start to modify it. So I don't need this part because we know the data set. I don't need to load in the data set because that's already loaded in Power BI. So I don't need to worry about the index. I also don't need to visualize it because this is all going to happen in Power BI. I am not testing the model in Power BI, so I don't need these data frames. What I do need is creating the model, and we're going to have to modify this. So I go back over. Let's put this in. So we can see that says dataset holds the input data for this script. So we can't use df. And we also need to change this to dataset, but we also need to tell it which columns are needed. So there's our dataset, and we only are using values. So I'm changing those to values. And then we're recreating the prediction column. The model expects a two-dimensional data set, so we need to change this to make it two-dimensional by putting double brackets over values. So that will bring in a two-dimensional data set and two-dimensional data set instead of the one-dimensional array here. And let's run that. And let's see what our error is. Oh, data is not defined. So data set. There we go, data set. And I also didn't change this one. So data set. That should do it. Okay, so now we're given a table, and I'm going to open up that table, and we can see the results. So we have our value, and we have our predictions here, which are 1 and -1. So first thing I'm going to do is create an index by going over to add column and going to index. And the reason I'm creating an index because I want to create a merge of these two so I can have the predictions with the date, because the date is over here. So I'm going to create another index column here. And then I'm going to merge a new data frame. So I'm going to go over and go to merge queries. So I'm going to merge these two queries as new, and I'm going to merge them with the index. So I have the machine data, my copy here, and I'm going to connect those two, and we can see that all the values matched. And now that I have this merge in, I can open this table with only the predictions. So I'm going to just bring in the predictions. I don't need the prefix, don't need the index, I don't need the values, and I don't need the date. So now I've brought that in. And now we can start visualizing. So I'm going to close and apply that. So we can start visualizing what we want to see. I'm just going to make a scatter plot, bring that in, and I'm going to use our merge, and I'm going to use the index for our x-axis, and I'm going to use the values for our y-axis, and then for our details I'm going to bring in the date and not summarize that. Instead of the count of index, I want the sum. And now we can see the scatter plot that we saw before, and we can see all the values there. I'm going to bring in the predictions for the legend, and now we can see where our values fall in terms of what is the -1, which is our outliers, and 1. And of course we can go in and change that to outlier and inlier. And then we can also go and alter the sensitivity, because we know it's set at auto right now, but we can go in and change it. So I'm going to go to transform, and I'm going to go to our merge table. Oh, sorry, I'm going to go to our second table here where we ran our Python script. I'm going to open up the run script where we have our model, and I'm going to write contamination, and then I'm going to set this to 0.05, and I'm going to run that model again, so that's going to make it less sensitive. Then I'm going to close and apply, and we'll see how our results change. We see a little bit less here. So the ultimate goal would be to visualize this. We can also use this so we can see our model and contamination. I'm going to enter data to create a new table. And I'm just going to call that put all my calculations in that table because I want to use a line chart to use the percentiles also. So I'm going to get our merge data. First, I'll use the date. I'll use the value. I'll do not summarize. Turn this into a line chart. And then I would like to see percentiles here. So I can, now that we have it in a line chart, we can go over and we can create boundaries here. So if I go down to percentile and I put add, I can change this value here to the 95th percentile. Then I can also alter the color. And I have all this visualized. I'll show you in 1 second. And then I can also add the label here. And I'm going to use the name in the value. We can alter that name to 95th, so we can see that only 5% of the data is going to be over this part. I'm going to add another percentile, and I'm going to change this one to the 5th percentile. Change that to red also. And then I'm going to name that let's 5th, and then let me change that one to 95th. So we know only 5% of the data is down here. And let me just add that to label to that, name and value, go back up. Where's my label? There we go. And then the name and value, since it's blue there, but you get the gist of it. And what I did was I took these two core visualizations, which I thought that were very telling to what was going on with our data, and I created a dashboard. And we can see once we have this all visualized, where we have our backgrounds and everything, this is just a running average in the middle of that. This is our percentile, a 5th percentile. Here's our data and our outliers in white. And we can also put a slicer here that will update the data as we move that slicer. I hope that helps. Thank you.